This is the Primary Math 4 Week 2 class recording to just go over in advance of your student working the Week 2 material to help them to know what all is going to be in the week and help you know how to plan your week. So in the syllabus this week, we're working some out of each of the 3 books. When I scheduled my own children to do Singapore math, I usually had the workbook, the intensive practice, and the word problems book. And rather than doing one book, all of one book in a day, we would do a few pages out of each of these all week long, mainly because sometimes the intensive practice is pretty intensive, and it was good to break that up and do some as we go. And some days I would pick, which ones to do or whatever. And as you look at those, we can break it up. But again, as we talk about today, I'm going to show you some of the pages that are heavier and more intense, and we'll talk through some of that. But just let them do a couple pages out of each of them every day, and schedule it based on how many days you're going to work this week to finish the pages that are assigned on the syllabus. Starting out in the workbook, we're going to be working this week exercises 6 through 10. And in those pages, let's talk through those assignments and understand the requirements. First thing off the bat, Singapore Math is excellent with this. It always goes from concrete to abstract. The very first thing we're going to do is look very concrete at rounding numbers. And when you're rounding a number, the question is, which one is it closest to? That's the idea. Where is it closest to? Students have a hard time rounding, but when they start looking at it like this, you're looking for the closest 100, and you see on number 1 where 130 is, and you can see clearly that it rounds the nearest 100 is 100 and not 200. And then, of course, if it's dead even, if it's in the middle, the standard is we always go up. And so you can see that. But here on every one of these, they're looking to see where it rounds to the nearest 100, and that's just going to be done visually. By the way, also they snuck in a good thing. 960 to the nearest 100 is going to go to 1000. So let's make sure that we realize that that goes to 1000, also known as 1000, but we want to make sure that 1000 is how we see that number when we're rounding that way. And then you continue on the next page, bottom of the page on number 17 and top on that whole page, they're not doing anything visually. So we've gone quickly from concrete to abstract because we're in primary 4, and so we're expecting them to have already done some of the abstract in the earlier year, or the concrete in the earlier years, and so they move pretty quickly. On exercise 7, when they're working these problems and we're talking about rounding to the nearest 100, it becomes simply a hundreds game, and we're working with hundreds. And so I'd encourage you, like for example on F, it becomes 900 minus 300, and we really want them to understand that that's 900 minus 300 is 600. And so again, it's all about place value and understanding that if you have 9 of those and you take away 3 of those, what you have left are 6 of those. And so the hundreds work out that way. When you go on over to the next page and you look at, say, problem D, one of the things that I want you to recognize, and actually the problem C would be more what I want to demonstrate with this. What I want you to realize from this is that when you're rounding, and I'll just go straight to the rounded numbers, 1000 minus 200 plus 100, or maybe I should say 1000, take away 200 plus 100. You've probably done and remember that the order of operations is coming, and we'll talk about that. But although we normally in order of operations we talk about left to right, addition and subtraction, it is helpful for students to begin realizing that altogether we have 11 hundreds, and we're taking away 2 hundreds, which means we're going to have 9 hundreds. And I'm separating the numbers not to make it confusing or look weird, but because I want students to really see and think in terms of place value and hundreds and not be confused by that. Continuing on, some things that your students may or may not know yet. In exercise 8, we start talking about factors, and factors are important. Factors will be part of your math for a long time, and they're something that a lot of the older math will come back to when you're factoring quadratic equations. You've got to be able to come up quickly with the factors of a certain number. So some of this feels tedious, and it takes a while to get there, but it's a good idea to spend the time and make sure you get all of the factors and factoring figured out, and to have a plan by which to do it. So I'm looking actually at exercise 9. Exercise 8 does it, but it's all very self-explanatory what you're doing. When you get to exercise 9, the first problem says, is 2 a factor of 35? What I would suggest on these problems is to let your child do it the easy way. There's lots of room. You could work out the division. It does even say 35 divided by 2, and it writes it out this way. But I think it's very important, and there's plenty of time for the rest of the math, to look at that and say, well, no, 2 is not a factor of 35 because it's not even. 35 is odd. So no, it's not a factor. And I would rather at this point your child be very comfortable with the mental understanding of that, more so than the division of how to solve that problem. When you get to 3, a factor of 45, that introduces some, what I'm going to call them tricks, or some ways to know things. So let's talk about things that are multiples of 3. Maybe you know this, maybe this will be a grand revelation. Every multiple of 3 has this fact true. If you add the digits and you have a multiple of 3 as the sum of those digits, right? That tells you that it is a factor. It is that 3 is a factor. In other words, 3 goes into it evenly. So for example, looking at the number 45, we want to know, is 3 a factor? 4 plus 5 is 9. 9 is a multiple of 3. 3 times 3 is 9. So that tells me, yes, 3 is a factor. And that always works. Take the number 1,560, make it up as I go, 64. If I add those numbers together, 1 plus 5 plus 6 plus 4, I get 16. There's my 10, and there's my 6. 16 is not a multiple of 3. 3 times 5 is 15. 3 times 6 is 18. So then that tells me that no, 3 is not a factor. 3 is not a factor of 1,564. I know that because I added it together and I find out that it's not. At this point, I would rather our students learn that than necessarily be able to find the factors. Let's talk about a couple of other tricks that we know. Is 4 a factor of a number? Well, what you need to know is that, of course, it has to be an even number. And then if you divide it by 2, that also has to be an even number. So if you're looking, like I'm looking at the chart on the bottom of page 2, the quick way, without doing a division problem for every step, that's what I don't think is necessary on this page. Without doing a division problem on every step, I want to know 36 is 4 a factor. Maybe your child says, well, 4 times 9 is 36, so yeah, it is a factor. That's good, always a good thing to know. But also, if you divide 36 in half, think of 3 10s and 6 1s. If I divide it in half, I have 1 10 goes this way and 1 10 goes this way. I have these 3 go to this group and these 3 go to this group, and this 1 10 has to split and send 5 up and send 5 down. So altogether I have 18 is half of 36. Now all of this is a good thing to have your child do and to be able to do visually and mentally, but they don't have to draw it every time. When they begin to realize, okay, well, there's 2 10s divided into two groups, so it's a 10 in each group, and of that 16 I have 8 in each one. So that, when I divide 36 by 2, I get 18. 36 is an even number. When I divide it by 2, that's an even number. 18 is even. Of course, you have to have 36 be even in the first place. Okay, but a factor of 4, you have to be able to divide it by 2 and divide it by 2 again. So if the number is even and half of the number is even, then yes, 4 is a factor of 36. Looking on down the row, if you look at number 75, 75 is not even, so it can't possibly be a factor. Of course, you know that 5s, all the factors of 5 are going to be in the ones digit, is either a 5 or a 0. Okay, if it's a factor of 5, that's definitely true. And so for that page, that's all we have to know. Continuing on with the next page, you're looking at common factors of the numbers. We want to know if 4 is a common factor. Again, rather than doing all the division, I would see if I can divide it and divide it twice and make sure that it works. Then we get down to the problem on number 4, and you're trying to find all of the factors, for example, of 72. This is where it gets a little tedious. This particular page, I wrote down that this particular page, these two particular problems are the most tedious part of this week. And so you might attack this page, I spelled tedious wrong, you might attack this page, I believe, in a time when you can spend time and do it and not at the very end. Maybe they do that one page by themselves, or part B and C on its own day if you can have enough time to do it that way, because it's important to be able to stop and look at it. So let me talk about how I would look at 72 and finding all the factors of 72. Of course, we know that 1 times 72 is a factor. 72 is even, so it's going to be 2 times. Mentally, I'm going to look at my 7 tens, and I know there's 3 in each group with 1 left over, and that gives me 12 ones, so I'm going to put that into 2. I want to know if 3 is going to go into it. Since 7 plus 2 is 9, then that tells me 3 is going to go into it. And so when I know 3 goes into it, here's what I do, and I don't think we've done division at all before. Rather than dividing by 3 and just doing the algorithm, and that's fine. If your student already knows how to do that and they're very comfortable with it, great. But if you want to have a more intuitive way of doing division, let's talk about this. If I want to divide it by 3, I know that 60 is a count by 3 number, and 60 and 12 makes 72. I'm going to break 72 down into numbers that I know what it goes into. And then I know that 60 divided by 3 is 20. 12 divided by 3 is 4. So that equals 24. And I do this in writing now, but as you get more and more able to do it, you begin to be able to look at the number and do that in your head mentally without writing it down. If I continue the algorithm, which is 3 goes into 7 twice, 2 times 3 is 6, subtract, bring down the 2, and I do it this way, of course I end up with the same answer because the answer is 24, but this doesn't ever inspire me to do math mentally. If I do it this other way, I'm teaching myself to look at that and break it down to 60 and 12 and think 20 and 4, it's going to break down to 24. So then I want to know if 4 is going to go into it. And I'm going to look back at 2. When I divided by 2, I got an even number. So half of that number is 18, and I know that's going to work. Because to divide by 4 means to find half of half. In other words, if I took 72 and I divided it in half, and I got 36 in each part, then if I divided it in half again, that 36 became 18 for each of my parts. So it's a very good thing when you're writing them down not to do every one of these as a brand new problem. You can look at it and figure it out quickly. because dividing by 2 is even, so I just have to divide that number in half to get the divided by 4. I don't have to go back to 72 and start over with 72 divided by 4. If I did do 72 divided by 4, I would think in terms of 40 and 32, because 40 divided by 4 is 10, and 32 divided by 4 is 8, and that does give me 18. I would think in terms of 5. Of course, 5 is not going to work because it's 72, and it has to end in the ones place with a 0 or a 5 in order to make a 5 a factor. How do I know if 6 works? Well, 6 is wonderful. 6 only works if 2 and 3 work. Since 2 and 3 both go into 72, I know that 6 will work. So it's nice to know before you start dividing, can I figure it out first if it's going to work or not? So 72, how am I going to divide it? 60 and 12. If I divide by 6, I get 10. Divide by 6 and I get 2. And so 6 times 12 is 72. I would not ask them to memorize necessarily the multiplication tables to get that. I would rather they quickly and mentally just look at the number and go to the side, and preferably going towards mental math, but right now doing it that way is certainly fine. 7 is a prime number. There's no way to do it except think about 7s, but 7 is easy in this case because I have 70 and 2, and of course 70 divides by 7 evenly, but 2 doesn't work, so I know from that that 7 is not going to work. 8 will work if 4 is an even number. So to know if 8's going to work, I need to know if that's an even number, and since it is an even number, I can just divide it by 2 and say 8 times 9 is going to be the factor. Now, when you get to the numbers that you're starting back to repeat, you're finished. So after 8, of course, I would try 9, but I already have 9 as a factor, and from then what I know is I could try 9 and it would work. 10 and 11 would not work. 12 would work. The rest of them wouldn't work until I got to 18, 24, 36, and 72. And so once you've repeated something, you're finished. So all of this could be done on scratch paper. All of it could be looked at that way. When you are finally finished, they showed you the format to write the answers. You're just going to say 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9. All of these give you 72. Again, it's a bit tedious. All right, so that is finding all of the factors of a number. Again, those two are rather tedious, but it's important to know the little tricks and steps in there to make that as short as possible. Finally, in this book on exercise 10, we have the idea of multiples and what your student needs to begin to figure out, and it should be an intuitive thing, but just in case it's not, you can always kick them into seeing it. When you're working like on A, you have the multiples of 3 and the multiples of 2. Once you find your first one for both of those, the next one will be a multiple of 6. Since 6 is the first common multiple, the next common multiple is 12. The next one after that would be 18, and then 24. And so what you see when you look at each of those problems on down, you see in the second one that 8 is the first common multiple and 16 is the next one. And then you see that 18 is the first common multiple and 36 is the next one. So common multiples are also multiples of themselves. Once you find a multiple, so like in part D, once you go all the way up and realize that 24 is the first common multiple of 8 and 6, if your student has realized it by then, and if they're fully engaged in thinking about the material, they can look at that and realize, okay, my next one is going to be 48. And you don't necessarily have to find all of the multiples of each number between there. You can just find the first one and realize the next one is going to be a multiple of the first multiple. So that is the material in the workbook. Now let's move on and talk about the intensive practice book. We're working on that one on page 9 through 17. So again, much the same information, much the same skills that we're working on, but when we look at this, we realize that that it's going to be more intensive in the intensive practice. So I generally get through a lot of the workbook material on the easier introduction before I go into the depths of this. And again, you can kind of figure out your schedule as you go with your student. Remember, it's a factor if it divides evenly. That's what we're talking about when we talk about a factor. So on page 9, all those questions, we're just trying to figure out if it's a factor. Again, 3 is a factor if it adds to be 3, a multiple of 3. 6 is a factor if it's even, if 2 and 3 go into it. So if it's even and it adds to a 3. 8 is a factor if half of it is even and half of that is even. Actually, 8 would be half and half and half. You have to have a lot of halves, make it 8 even. So continuing on, you've got the table to figure out. There's really not a trick for 7 other than just doing the division. It just goes looking at the numbers and counting by 7s and seeing which ones go into it evenly. I'd like to talk about page 10 in the intensive practice, number 20, part C. And when we look at that, we're trying to find the common factors of 32 and 54. So again, it's tedious enough because you've got to go through all and find all the factors. Always start with 1 times 32. I know it's going to have a 2 go into it because it's even. Again, mentally, I look at 32 and I think of 3 10s and 2 1s, and I divide it into 2 groups by putting an even amount in each place. So that's how I get the 16, because down in this group I have a 10 and a 5 and a 1, which makes 16. Again, that just takes practice to be able to be very efficient with it. I want to know next, does 3 go into it evenly? Since 3 plus 2 is 5, and 5 is not a multiple of 3, I know 3 will not go into it. Does 4 go into it evenly? Since 2 is an even number, I can take half of that. 2 times 16 means it'll be 4 times 8. I can tell that 5 is not going to go into it because the last digit is a 2 and has to be either a 0 or a 5. 6 is not going to work. If 2 and 3 work, then 6 will work, but 3 was not a factor, so that won't work. I could try 7. To do that, I just have to count by 7s. I know that 7 times 5 is 35, and 32 isn't far enough down to make that work. The next number I would try would be 8, and I already know that 8 works. Remember, once I've come up with a repeat, then I'm through. So I know, I can erase the rest of these, I know that it's 1 times 32, 2 times 16, and 4 times 8, and that those are the only options, those are the factors of 32. Now, being smart about this, we could do a couple of things, because it's trying to find the common factors of 32 and 54. So I know that 1's going to work, of course, and I know that 2's going to work, of course. I don't care about 3 because it's not a factor of 32, so it can't be a common factor. Now, I could find all of the factors, but I think it's important to be smart. It says find the common factors of the pairs of numbers. Once I found all the options for 32, these are the only 6 numbers that I care about. Are any of these a factor of 54, or not. So I found that 1, of course, is. 2, of course, is. How about 4? Well, 4 is not because 27 is odd. So I know that 4 doesn't work. And if 4 doesn't work, 8 doesn't work, and 16 doesn't work, and 32 doesn't work, because all of those would have to work. So the only common factors are 1 and 2. Now, depending on the age of your child, depending on how much time you have, depending on how much practice and how much patience they have, you could continue on and find all of the factors of 54 and then find out which ones are in common. But I think it's important to point out to our students that if they do math smartly, sometimes they can do less work because they are following the instructions and figuring it out that way. Again, on page 11, we have that same point of discovery that I talked about on in the last book. On page 11, it wants to know the first common multiples. And so when you find, this is actually page 11, number 23, you're finding the common multiples of each of those. And at some point, I hope that they discover the fact that when you find a common multiple, you can just use that as a multiple itself, especially by the time you get to 7 and 6, and you're finding the multiples of 7 and the multiples of 6. The first common multiple that they have is 42. And by then you've counted 6 sevens and 7 sixes. If you've got to count all the way to the next common multiple, you've got to count by 7s all the way to 84, count by 6s all the way to 84. But if we've discovered the fact that a common multiple becomes in itself the multiple for all the rest of the common multiples, then once you find the first one, you can discover the next one without counting all the way up. And I think it's an important thing for them to discover, even if you have to kind of poke them in that direction, because that's a good thing for them to see. Problem number 24, part D, is a word problem that I think is worth talking about. It tells us that a teacher has 42 pens and 56 pencils. And the question is, she wants to distribute them to her class of 14 preschoolers. And these 14 students, 14 preschoolers, and it says they want each child to get the same number of pens and pencils. Okay, when I read that, that just brings up a lot of questions in my mind. Do you mean the same number of pens and pencils together, combined, or the same number of pens as there are pencils? What do you mean by the same? What is the same number? The number of pens and pencils, the number of combined, or that always makes me confused. But what they want to know is that it's the same number of pens for each student and the same number of pencils for each student. And so if I have 14 students, and maybe off to the side somewhere we do a count by 14 number, 14 and 14 is 28, then the next one is 42, which is kind of convenient. And then the next one is 56, which is extremely convenient. So that tells me that 14 times 3 is 42 pens, and 14 times 4 is 56 pencils. So the answer is that each student gets 3 pens, and each student gets 4 pencils. So what happens is that each student gets the same number as all the other students, but it's not the same number of pens and the same number of pencils. Those kind of wording always causes me to pause and learn and think. As you know by now, all the word problems to this class are on the recording and the solutions recording posted online that you have access to on the Primary Math 4 page. I do want to bring your attention to one thing in the intensive practice book on page 14, problem number 7. When they have, I'm sorry, I made a note to myself that actually isn't true. I'm sorry, okay, let's look at 7b. I guess that's 7a. It tells you, 7a it says round to the nearest hundred, and that's nice when it tells you that. On 7b, it tells us that 28 girls have 273 beads each, and it wants the estimated number of beads that they have in total. Well, how do you estimate something? How do you round it? You know, if I round this to 30 girls, that's rounded to the nearest 10. Does that mean I need to do 270 beads and multiply that? The way the book does it, and again, when I look at this problem myself, I think if this is confusing or not, the way the book does it is it rounds the girls to the nearest 10 and the beads to the nearest 100. And so if 30 girls each have 300 beads, that is 3 tens and 30 tens. 3 times 30 is 90 tens. That means there are 900 beads. Okay, again, find whatever units they have in common. I don't have 300s in the girls, I just have 3 tens. So if I'm going to talk about tens, I have 3 tens and 30 tens. And 3 times 30 is 90, or 90 tens. And so, yeah, so hold on a second. I apologize, I'm getting my mental math rules mixed up here. When we're adding and subtracting, of course, we go to tens. I apologize. It's still that we're going to round to 30 and 300, but the 3 times 3 is 9, and when you're multiplying and dividing, I don't know how in the world I got that confused in my head, we have 3 zeros to carry around with it, and so the 9 becomes 9,000 beads. Of course, it's not 900 beads, that wouldn't be nearly enough. That's when I wrote it and I looked at it, I'm like, that's not enough, I'm doing something wrong, had to pause and think what's going on with it. So it seems odd to me sometimes when they round one number to the tens and one number to the hundreds, but when they're just getting an estimate, they're just trying to help us to understand when you want a nice round number, you've got to start with nice round numbers. And so starting with 30 and 300 is not a wrong thing because they rounded that way. Same thing with number 8. When you're asked to have an estimate on 8A and you have all these different numbers, they round everything to the tens in that case. And if your student rounds to something different, let me just write this down and make sure we're understanding. If the rounding is not defined, in other words, they don't say round to the nearest 10 or round to the nearest 100, and that means it's subjective, right? It's left to your own interpretation of what it is, then you need to consider your student's answer based on how they rounded. So if they chose to round differently than the book did, if it didn't tell them how to round, then consider their answer. Not necessarily, you might say, you know, on this problem you could round this way, and they might say to you, how do you know? Well, good luck explaining that one, because it doesn't appear to me that there's necessarily a definite way to do it. I think that there's just a way that you could, sometimes they do it one way and sometimes they do it a little bit of a different way. And so that's not very comforting, I know, but that's how it is. I want to take a couple of minutes. They are on the recordings, and I know you can click over and watch them, but I wanted to pick a couple of standard kind of problems, the harder ones, but the ones that I think are important to kind of be able to walk through, and maybe just seeing that on this recording also will help you to not have to switch to too many recordings and see it clearly. So in the intensive practice book, I'm looking at page 16, there's problem number 13, and this problem is going to require a chart to solve, and so I just want to kind of talk through that a little bit. This might even be a little bit different than I drew it in the on the recording, just because there's a few ways to do it, and so if this way works great for you, great. If not, you could always do it the other way. You could look at the recording and do it the other way, but just to say, you know, some of these things you can really only work with guess and check, and having a good way to work through the material is helpful. So if you have a number of students, and what we're told is that the teacher, if they give 3 stickers per student, you have 75 stickers left over. And if you give 6 stickers per student, you need 30 more stickers because you'll run out of stickers too fast. And the goal is to find out what combination of numbers of students are going to make the numbers in these 2 outside columns the same. Because he has some number of stickers. We don't know how many they are, but he has a number of stickers. So As an example, let's just start with something that we can wrap our head around. Easy math is a nice thing. If he has 100 students, then if he gave everybody 3, he would give away 300 stickers. And we're told that he'd have 75 stickers left over. So that means he would have started with 375 stickers because he gave 300 away and he had 75 left. If he gave 6 to each student, then he would have needed to give away 600 stickers, but he ran out 30 stickers too soon. So that means he must have started with 570 stickers. Clearly, the 375 in the first pink column and the 570 in the other pink column are not the same. Now, notice what happens. I need this number to be smaller and this number to be bigger. And so I'm going to decrease my number of students overall. There's too many. I have no idea where to go. I'm going to just pick a number. I'm going to pick an easy number to do the math. And so if I have 50 students and I give each of them 3 stickers, that's 150 stickers. And if I have 75 stickers left, that's 225. Now 50 times 6 students apiece, or 6 stickers apiece, would be 300. And if I subtract 30 from that, then I have 270 stickers. Notice that I'm much closer together. I was well over 100, almost 200 apart. Now I'm only, 50 apart. So I'm getting closer to the right number. And so if I go down, how many do we go down? Where do we go from there? It's guesstimate, right? You can just guess however many. And I will tell you, this is a great problem to give your child a calculator with and ask them to show a chart like this. They can organize the chart differently, look at the recording, see another way to organize the chart, but you can do the chart differently. And the point is, can you organize your information and come up with an answer, not necessarily can you multiply by 3 and add 75 in your head. If I had a student who was willing to work on this and try it this way, I would very possibly give them a calculator and allow them to use that to solve it. So maybe I would go from 50 down to 25, and 25 times 3 is 75, and that means there's 150 stickers. 25 times 6 is 150. That would mean there's 120 stickers. Notice I've now gone too far in the other direction. Whereas I had too big of a number on the right side, I now have too big of a number on the left side. Okay, so I'll magically decide 35 because I happen to know that that's going to work, because that's going to give me 35 is going to give me 105 in this group, and add 75 is 180. In this one, 35 times 6 is 210. Subtract 30 and I get 180, and that tells me that I have the right amount, because again, the man started with the same number of stickers either on both groups, and so he must have had 35 students, 180 stickers. And because you've got all that information, there's really no way to solve it without doing a good, solid guess and check method. And it's not a simple thing, but it's a great time to hand them a calculator and let them learn how to use a calculator for this kind of a setup and this kind of a organization of your data. Okay, and in the word problems book this week, of course, you're working on page 10 to 18. Yeah. The word problems book, you're working on page 10 to 18. And it's actually the challenging word problems book. Make sure when you get to that break between the two that you work through the examples with your child. They're all drawn there. Again, I could go over these, but they're all in that other recording, so I won't go through the rest of them any further. But that is all the information for week 2 in primary 4.